Hello my dear students, welcome back to another session in number system. In our previous session, we had a recap of kinds of numbers and also learned how to find out the rational numbers between any two rational numbers, isn't it? In today's session, we are going to learn how to represent irrational numbers on the number line. Do you have any ideas on how we do that? A real number is either rational or irrational. So, we can say that every real number is represented by a unique point on the number line. Also, we can say every point on the number line represents a unique real number. So, here comes what are irrational numbers? Any number, let's say S, that cannot be expressed in the form of rational number, that is P by Q form, where Q is not equals to 0, is called an irrational number. For example, root 2 is an irrational number, root 3 is an irrational number, pi, and also we can say 0.10110111101110, etc. All these are irrational numbers. Also, the decimal expansion of an irrational number is non-terminating, non-repeating decimals. So, we can also say non-recurring decimals. So, non-terminating, non-recurring decimals. Okay, so here 0.1011101110, etc. This is one of the example of non-terminating and non-recurring decimals. Moreover, a number whose decimal expansion is non-terminating, non-recurring is, of course, it is irrational number. Now, let us see how we can locate some of the irrational numbers on the number line. So, watch carefully. This is one of the important concepts of this chapter. Okay, locate root 2 on the number line. How do we locate root 2 on the number line? We have seen natural numbers, whole numbers, rational numbers located on the number line. Then how come root 2 can be on the number line and how we locate it? So for that, take a number line and draw right angle triangle OAB on this number line. So here I am marking 0 as O and 1 as A such that OA is equals to 1 unit. Next, take another point B which is 1 unit away from A, that is AB is equals to 1. Here comes triangle OAB is a right angle triangle. Now, find the length of OB. How do we find the length of OB? Since it's a right angle triangle, to find the hypotenuse, we can use Pythagoras theorem, isn't it? That is, square of the hypotenuse is sum of the squares of the perpendicular sides. So that is here OB square is equals to OA square plus AB square. So here OB is root 2. When you simplify, see here OA is 1 and AB is 1. So 1 square plus 1 square which is equals to 1 plus 1, that is 2. So we need the hypotenuse, not the square of the hypotenuse. So I am transposing this square to the other side. So OB is equals to square root 2 units. So we got root 2. Now the main part is to locate root 2 on this number line. Now using the compass with O as center and taking OP as radius, draw an arc intersecting the number line. Let's say it meets at P. So the P which is represented as root 2 on the number line. In the same way, you can locate as many irrational numbers as we can. We will discuss more representations in our upcoming digital classes. Keep practicing guys. See you soon with another concepts. This is Sabita signing off.